Okay, so welcome to section 4.2. So 4.2 is conditional probability. Conditional probability. Okay, so let me go ahead and define it. So conditional probability let's let event A and event B, let's put B in orange this time, be two sequential events. So be two sequential events, meaning one follows after the other. Sequential events. So then, the probability of event B, so the probability of event B given that event A has already occurred, so that event A has already occurred, is denoted by so the probability of, well, I want to find the probability that event B happens given that, so a straight up and down line, event A has already happened. So this is read aloud. The probability of B, the probability of B given A. So that's how we read this aloud. So given A. Okay, so let's try this intuitively without formulas for the time being. So for example, actually let me move that down. Okay, so what is the probability of picking a club? So what is the probability? Is the probability of picking a club after choosing 3 diamonds. So after choosing 3 diamonds from a deck of cards. Diamonds from a deck of cards. And this is without replacement. So without replacement, meaning once you've chosen those cards, you don't put them back. And this is why it's going to be conditional. So I'm going to let A be the event that happens first. So that's going to be choosing 3 diamonds. Okay, so let event A be choosing 3 diamonds. And let's let event B be choosing a club. And actually, I wanted to change this to orange, didn't I? So let's keep B in orange. Okay, so now what I want to find is the probability of event B given that event A has occurred? Okay, so I want us to think about this. If I have chosen 3 cards that aren't clubs from the deck, the 3 diamonds, do you agree that there's only 49 cards remaining? And of those 49 cards, do you agree that 13 are clubs? So let me note this. So we chose 3 diamonds. Hence 52 minus 3 equals to 49 cards remain. And since I chose, actually let me do that in a different color, orange, darker orange. So we chose 3 diamonds. So all clubs left. So I can choose, there's 13 left. So hopefully that makes sense. So this is a conditional probability. And let's note something. Not that I'm going to use it just yet, but let's note that the probability of B given A, so the probability of B given A is, sorry. I wanted to say something different. Oh, okay, so the probability of B and A, or A and B, is going to be the probability of A times the probability of B given A. That's what I wanted to do. So times the probability of B given A. Okay, so I need to caution one thing. Caution or caveat. So we always need to consider whether A and B are overlapping events. So always need to consider. Whether A and B are overlapping events. So in the above, choosing 3 diamonds and choosing a club are not overlapping at all. They're completely distinct or disjoint. Okay, so for example, so what is the probability of choosing an ace? So what is the probability? Is the probability of choosing an ace of clubs, followed by another club. So followed by another club. Okay, so let's let event A be picking the ace of clubs, or picking an ace, or the ace of clubs, since there's only one. So the ace of clubs. And we'll let B be the probability of picking any other club. Okay, so the probability of, this is followed by, so this is not given. This is going to be and, right? I want both to occur. So the probability of A and then B. So I claim that that will be the probability of A times the probability of B given that A has already occurred. So the probability of B in purple given that A has occurred. So I want the probability of A and then B, right? Okay, so let's think about this. What is the probability of picking the ace of clubs? There's only one, and since I'm picking that one first, I know there's 52 cards, and the probability of picking the ace of clubs is 1 in 52 cards. And I'm going to multiply that by the probability of choosing any other club given that I've chosen the ace of clubs. So how many clubs remain? Or how many cards remain? Well, there's only 51 cards that remain. And there's only 12 clubs that remain, right? So this number comes from one card already chosen, and of course that was our ace of clubs. And then the number on top is remaining number of clubs, right? There's only 12 if I chose the ace, right? Okay, so we get a very large denominator, but I'm just going to leave it like that. And hopefully that makes sense. The algebra you can do on your calculator. Okay, so let's do another one. Usually this one is a marbles one, but let's call it dice. So for example, so what's the probability? So what is the probability? The probability of choosing, let's do 2 green dice, choosing 2 green dice at random from a drawer, or a bag, from a bag containing 9 green dice, 7 blue dice, and 5 red dice, So much like with the deck of cards, I need to know how many dice are in total. So note, there's going to be 9 green dice. So 9 plus 7 blue dice, 7 plus 5 red dice, so plus 5. So that gives us 21 dice total, so 21 total dice in the bag. So now I can figure out my probability. So, well, first I need to what colors should I use? So let's let event A be picking the first green die. So picking the first green die. And let's let event B be picking the second green die. So picking the second green die. Okay, so the probability, this would be and, right? Of first picking one green die and then picking a second green die. Well, I claim that that's going to be the probability of picking the first green die times the probability of picking the second green die, given that I've already chosen the first. Okay, so what is the probability of picking the first green die? Well, do you agree that originally there are 21 dice, of which there are 9 green die, right? So that should be, let me do that in orange to keep it color-coded. So there's 9. That's a probability of A, 9 out of 21. But now let's calculate the probability of B, given that A has already occurred. So if I've already chosen one die, then there's only 20 dice remaining. And if I've already chosen one green dice, do you agree that there's 8 dice remaining instead of 9? Because my first choice was the first green dice. Okay, so the rest is algebra. What do we have here? If we care to, what does this reduce to? So 3 goes into 9 3 times, and 3 goes into 21 7 times. Then over here we have 4 goes into 8 twice, and 4 goes into 20 5 times. Okay, so that gives us 3 times 2, or 6, in the numerator, and 7 times 5, or 35, in the denominator. Okay, so now let's look at a table as opposed to dice or cards. So for example, so consider the following table. Consider the following table. Okay, so what I'm going to do, let's see, I'm going to have a category for feline. I'm going to have a category for canine. And I'm going to have the totals. Okay, so now I'm going to have domestic. Feral. And then the total. Okay, so what do we have here? Okay, so let's do felines in blue. So let's say I have 30 domestic felines and 15 feral felines for a total of 45 felines. And let's do canines in purple. So let's say I have 50 domestic canines, 5 feral canines for a total of 55 canines. So now let's sum up the first column. Do that in orange. So do you agree that the domestic animals, I have 80 domestic animals, and feral animals I have 20, for a total of 100 animals? And do you agree that that 100 is both 45 plus 55 above here, but it's also 80 plus 20. So this table works out. Okay, so this table is given. So what I want to do is I want to evaluate the following. So evaluate the following. So number one, what is the probability of being feral given that you're a canine? Okay. So I want to know the probability of being feral. So what color shall I associate with feral? Shall we do feral in green? So the probability of being feral given that you're a canine, and canine was in purple, so I used the same color. Okay. Oh well, canine. Okay. Well, if I rearrange the formula from above, do you agree that the probability of B given A, I just divide by the probability of A? So I claim that this is the probability of being feral and canine. Yep. What's going on? Feral and canine divided by the probability of canine, right? Because this is the A in this case, right? Okay, so the probability of being canine. Okay, so let's look at the chart. What is the probability of being a feral canine? The intersection of both? Well, it's 5. Divided by the probability of being canine? Well, there's 55 canines in total, right? So I claim that it's 5 in 55. So the probability of being feral is 5 out of 55 canines. So hopefully that makes sense. And of course this reduces. 5 goes into 55 11 times. So this is 1 over 11. So the probability of being a feral, given that you're canine, is 1 in 11. Okay, so let's do this again. Let's say number 2. Let's find the probability of being domestic, given that you're feline. Let me do this in a different color. So the probability of being domestic, let's do domestic in, what shall we do, pink? Let's do pink for domestic. So the probability of being domestic given that you're feline, which was in blue. Feline. Okay, so I'm going to do the quotient, which is the and probability of being feline and domestic divided by the probability of being feline. So this becomes a probability of being domestic and feline divided by the probability of being feline. Okay, so let's look at the chart. How many domestic felines do we have? Looks like we have 30. So I claim that the domestic felines will be 30 divided by, how many felines do we have? 45 in total. Okay, so of the 45 felines, 30 are domestic. So it should be a probability of 30 over 45. But of course this reduces. 15 goes into 30 twice and into 45 3 times. So this reduces to 2 out of 3. Okay, so how about one more for good measure? So number 3, let's do the probability of being feline given that you're feral. So notice that I've swapped the placement of feline here. So I want the probability of being feline. So this now is B, given that you're feral. So what, did I use green for feral? Yes, I used green for feral. So given that we're feral. Okay, so that's going to be the probability of being feline and feral. Feline and feral. Over the probability of now being feral, right? Because feral is now what has to happen first. Okay, so let's go feline and feral. So feline and feral, it looks like there's 15 of those. So 15 feline ferals divided by the probability of being feral. So how many feral animals do I have? Looks like I have 20 feral animals in total. So this reduces. 5 goes into 15 3 times, and 5 goes into 20 4 times. So the probability of being feline, given that you're feral, is 3 out of 4. Okay, so I hope this makes sense.